Hey math class, so as promised, today we worked a little bit on subtracting fractions. As promised, here is the next step. Because the ones that we did today of subtracting fractions were all pretty straightforward. You find the common denominator and you go from there. Subtract your top numbers and it's all good. But I want to remind you of one special thing we have to do in subtracting of whole numbers. If I have a 7 in this problem, 57, and I want to subtract it from 100, I can't take 7 from 0. I can't just write the 7 down here and the 5 down here. What do I have to do? I have to borrow, right? And move all the way over and then do my math. The same sort of thing happens in fractions. And so I kind of want to relate it to whole numbers here, where we're borrowing. This is something that you already know how to do, right? And let's look at it in a fraction situation. What if I have a whole number 12 and I want to subtract a half from it? Hopefully you can look at that and say, oh, that's 11 and a half. Because usually we can all kind of think in halves, okay. If I have 12 things and I want to take half away from one of those 12, I'm left with 11 wholes and a half left. But let's sort of do the math for that. I can't take a fraction from a whole number directly. I have to have a fraction to take it from. And if you look, this is the fraction spot, right? If this whole number had a fraction, it would live right here. Well, I don't have one right there. It's like I have a big 0 right there, and I can't take anything, any number from 0 without borrowing. Okay, so let's do that. Let me erase that really fast. Here is how we borrow in fraction land, because it's a little bit different than whole number world, where we put, like the little tick mark and it becomes, 10 instead of just a 0. I'm going to borrow from this 12 and make it 11. Okay, and then the one that I borrow, I'm going to bring it over here and write it as a fraction that equals 1. So some number over itself, right? Remember way back to the very, very first day when we talked about fractions, at the very bottom of the handout that we did, we talked about how any number over itself equals 1, right? 5 over 5, I could make it 2 over 2, 3 over 3, all of these equal 1. I could make it 100 over 100, and so that's my point. I can make it anything, right? And there's an infinite number of things that I could make equal 1. Sorry, I said that wrong. Or make a fraction that equals 1. So I could pick anything. But since I already have a 2 on the bottom right here, I'm going to make it 2 over 2. Why, you might ask? Well, because then I have a common denominator. I mean, I could make it 4 over 4, but then I'd have to convert this guy, and that just doesn't make a whole lot of sense. So your bottom line is, if you can make anything over itself, that equals 1, and you can make this anything, make it the same number that's on the bottom of your bottom fraction here. Okay, so now I've turned this into a mixed number, right? Turn that into a mixed number. I can now subtract this fraction from this fraction because I've borrowed and filled the fraction 0. Okay, so 2 minus 1 is 1. My bottom number stays the same. 11 minus 0 is 11. So there's that 11 and a half that I just sort of knew that 12 minus a half was going to equal. Let's look at another example. Here I have 4 minus 8 elevenths. So again, it's like I have this 0 right here in the fraction spot. If this 4 was part of a mixed number, its fraction would live right here. Okay, so again, I have to borrow. I'm going to take 1 away from that 4. And then I'm going to bring the one that I borrow over here and write it as some number over itself. Where am I going to get that number from? Right there. Since I already have 11 on the bottom and I can make this fraction anything I want, I'm going to make it 11 over 11. Okay, so now 11 minus 8 is 3. My bottom number stays the same. 3 minus 0 is 3. Let's look at another one. This one has a mixed number on the bottom. So I'm subtracting, I have whole numbers in both of these. So I'll have to subtract my 2 columns. But I still have a 0 up here. I have nothing up here in that fraction spot for this 10. So I'm going to have to borrow. Make that a 9. Bring the one that I'm borrowing over here. Write it as a fraction. What am I going to pick? 16. Because I can pick anything, and I need it to equal 1, so I'm going to make it 16. 16 minus 5 is 11. My bottom number stays the same, right? Now I have 9 minus 3, which equals 6. So then I have to ask myself my 2 questions, right? Number 1, is this a proper fraction? And the answer is yes, it is a proper fraction. 11 is smaller than 16, so it's proper. My second question is, what's my second question? Oh, is it reduced down as far as it can go? And if you notice, 11 is prime. So I could only reduce it down if this number could be evenly divided by 11, which it can't. So I know that 10 minus 3 and 5 sixteenths equals 6 and 11 sixteenths.